question, and we put those in the search engine. Then the search engines retrieve the most relevant documents we have from our knowledge base. These documents can either be the most similar questions that have already been asked and answered in the past, or the most similar Russo documentation that might hold the answer, or the most similar FAQs, which are basically supervised question answering pairs that we input in our knowledge base that improve the accuracy and expand basically the reach of what Donkeybot can answer. Then all of these are retrieved and they are given to the answer detector to return the top K most probable answers. All of these parameters, how many documents you retrieve, how many answers are given, are of course configurable, and you can tweak them endlessly, basically. So as far as the answer detector goes, it's basically where the word neural comes from in the presentation's title. BERT and all of its variations are basically huge deep learning neural network models for NLP tasks, natural language processing tasks. And they have been initially developed by Google. They were released back in 2018. Over the last couple of years, immense amount of research has been done to them. Even recently, Greek BERT was announced by some researchers from ASOE. Anyways, these NLP models give state-of-the-art performance in many tasks, from NLP tasks, from classification to entity recognition. Of course, I use it for question answering. Recently, GPT-3 came out, but getting an API for that, an API key for that is impossible. You can see the old leaderboard from last year had BERT on the squad dataset be in the top, but the leaderboard has quite changed since then. To be more exact, the BERT model we are using on our approach is number 3 on the old leaderboard, basically fine-tuned on the squad dataset. The squad 2.0 dataset is the Stanford question answering dataset. 2.0 comes from combining 100,000 answerable questions with 50,000 unanswerable questions. And the important thing to note here is that the unanswerable questions have been adversarially written to look like the answerable ones by humans, of course. And it's important to have this in our dataset, since we need the bot to be able to say that an answer does not exist in some context or in some passage, which is, of course, very important. Thus, in the case where something like this happens, an answer does not exist, or the score, the confidence of our answer given is quite low, we can simply forward the request to the expert as it would have happened before the bot's existence. In a very, very, very high level, basically the documents that we retrieve through our search engines and give as input to BERT need to have two things. The question, of course, that needs to be answered, and some context, some passage. Basically the text where the answer probably resides in. And the output is basically a score, an answer, which is an excerpt from the text, and the start and end span of that. So generally, it's highly advisable to start from these models, these transfer learning pre-trained models, to get a minimum viable product up and running, get some baseline performance on your use case, and then when you have a data set, you can fine-tune it or even change the model and approach completely without messing anything up. Now, let's move on to some examples. I will mainly try to illustrate the caveats if you implement something like this and what I found to happen in our dataset. Example number 1, of course, keep in mind that these examples are probably going to be a bit Russo specific, since that was our use case. But if you have a different knowledge base, of course, it works the same, but just keep in mind the caveats that I'll mention. Now, here's an example where an answer is detected from the support emails that we have. And notice that how we phrase the query can have a big impact on the return answer. It's very important for the model to have a well-phrased query. So first we ask, when is a dataset considered touched by the system? And the answer is physically downloaded, when it's physically downloaded. While it's correct, it's quite lacking in detail. If we ask, when does a touch happen in the system? The answer given is when the dataset is used as input for a Panda task, or when Russo download is used to access the data. Now, in my opinion, the second one is a lot better and more detailed to give back to the user. And you can only see a small change in how we phrase the query can have a big impact on the answer. Generally, the answers detected from support emails in our knowledge base are not very good, either because of bad search engine performance, since currently we're only using the questions detected in past emails as indexes for the whole email body, and not when we're not indexing the whole email body, or because we have the cleaning issues that I mentioned before, specifically on the emails, where we have a couple of missing emails, not a couple, many missing emails, and many encoding issues. Moving on to another example, here we have something that is clearly answered in the Russo documentation, but while the answer is correct, in my opinion, it's for the wrong reason, which is something that might appear if you have, in your implementation also, if you have multiple data sources. So the question is, what are the supported databases for Rusio? The answer given is MySQL, Postgre, Oracle, and SQLite, which, yes, it's correct. But if you take a look at the source URL in the metadata of where this answer comes from, it comes from the installing daemons documentation, the daemons of the software package. And this is not where I would expect it to be. I would expect it to be in the database documentation. Thus, I would say it's an accidentally correct answer. So you definitely have to go through all the answers you detect and give back and analyze them. This also has a very high confidence score, so it won't automatically be detected as a bad answer, nor forwarded to a Russo expert. The second example is a good one, where the answer clearly exists in the documentation and is returned correctly. I had to put a correct one here. So how Russo user authenticated? Russo user is authenticated by credentials such as X509 certificates, and it's from the correct URL. So, of course, you can give back the URL to the user if he wants to go into more detail, read the documentation himself, see where the answer comes from. Now, finally, all of these examples, I'm going to say it for the third time, are quite, let's say, biased. They're not tested. I don't have an accuracy score, let's say 80% accuracy or something like that, because we don't have an evaluation set yet. So these are all one-off examples. I've tested around 100 of them over the past couple of weeks of the development period. What I can tell you is that if Donkeybot is asked something that clearly exists in our knowledge base and the query is similar to how we ask it, it has a very good accuracy and it's extremely promising. But if the answer does not exist in our knowledge base, obviously it won't be able to answer it. Or if it doesn't exist in a similar manner, or if it exists in the emails, the accuracy drops dramatically. These are the cases where creating an FAQ pair helps a lot. I mentioned them before, and I'm going to mention them here. As you can see an example, on the top left, we have a very simple question, which we would expect the bot to be able to answer. Rusio storage element, the RSC, is basically a domain-specific thing for Rusio. It's just an identifier, let's say, for entities, for logical entities of space. So the question was very simple. How can I rename an RSC? And it gave a horrible answer because it didn't exist correctly in our knowledge base. But then we can just create an FAQ. So if this is asked in the future, we can give back the most similar FAQ. What you might notice is that the confidence score in the FAQ is none. That is because the FAQ is simply retrieved from our knowledge base and given back to the user. It's not detected by BERT automatically from some passage, so, like the confidence score given back from the other set of answers. Here, with the confidence, you can use something like cosine similarity or other similarity metrics between the user's question and the question you have saved as an FAQ on your database. So finally, to illustrate another point, if something exists in your knowledge base, it probably will be answered correctly. Not probably, yeah, probably in a good percentage score anyways. The question was, can I add all changes across multiple files in one request? And this is not a Russo-specific question. This is a GitHub workflow question. It's quite general. And since we had GitHub issues in our knowledge base, the bot is able to answer it because it exists in our knowledge base. Someone had already answered this in the past. So the answer is, of course, sure. You can just add multiple changed files into the same pull request, and it has the tag of one of our contributors. That's actually Mario, my mentor, and Lasnik, anyways. So to sum up, keep in mind that these are promising results. They don't represent real life yet because it's not in beta. We don't have the UI, which puts me to my next point, the next steps of this bot's development. First, we need to create some user interface, which is what I'm going to be working now, besides the command line script that we're using, to be able to deploy the bot on a test server, gather user data, push it into beta, and all of that, improve the FAQs, fine-tune, yeah. Anyways, the creation of a custom named entity recognizer. This is basically an optimistic feature. I'm probably not going to implement it myself. Maybe it's for a future GSOC. Basically, you can create a custom nerd tagger for domain-specific language of Russia, like DIDs, RSCs, operations. DIDs are the data identifiers that we use. RSCs, like I mentioned, are the Russia storage elements, the logical entities within the dataset. So if you have something like this, you can create dynamic answers to the user. For example, if he asks, why is this RSC not working correctly? How much quota do I have left on this dataset? You can extract the question being asked and create a dynamic answer for it. So lastly, obviously, this is a 3-month prototype, so we have to iterate, refactor, and improve the current prototype. Now, some useful links. Of course, I'll upload the presentation on Slack if you need it. The repository of DonkeyBot, it has very extended documentation. I didn't get into a demo or something like that in this presentation. I want to give a higher level overview. You can find notebooks with examples and the actual code, how to use everything on the repository. I have to plug my GitHub and, of course, the Russia website if you want to check that out. Now, if there are no other questions, I'm going to stop sharing and you can ask me anything, or we can move on, of course.
Thank you, Vasilis, for joining. It was really, really insightful. I didn't know so many things about Google Summary of Code. Unfortunately, we don't have time also for you. You have to join Slack because, believe me, there are a lot of questions waiting there for you. And thank you for coming today to speak at our event.
Thank you, everyone, and I'll see you on.
Okay, bye. And our next speaker is Panagiotis. Panagiotis is going to tell us about AutoML. One of our previous speakers told us, advised us to use Google Cloud the tools and not reinvent the wheel. So Panagiotis Papaemmanouil is going to tell us more about it. Panagiotis, the stage is yours. Panagiotis, are you here? We have a small technical problem again, but we are going to solve it for sure. We're waiting for Panagiotis to come here and talk about AutoML. Until that time, you have the ability and all the time to watch my beautiful hair.
That's it. Okay, you can hear me now, I think. Yeah, can you confirm that? Okay, thank you very much. Let me just share my screen. Okay, just this window. So, I can see you everywhere now. That's it. Okay, you can hear me now, I think. Yeah, can you confirm that? Just close this window. Okay. So, hello everyone. Thank you for joining my talk. My name is Panagiotis Papaemmanouil, and okay, this is the first slide. Actually, okay. Thank you, Elias, for hosting such a great event. My name is Panagiotis Papaemmanouil, and I work as a data scientist for Meddoid AI. Well, in Meddoid AI, we build custom machine learning and AI solutions. Okay, here it is. Okay, now we're ready. Let me briefly introduce myself. Well, I hold the Bachelor of Science in Mathematics and a Master of Science in Data and Web Science from Aristotle University of Thessaloniki. Also, as I said, I work as a data scientist for Meddoid AI. And the last year or so, I'm focusing on financial machine learning, working for a major hedge fund company. Well, today I will talk about automated machine learning. Why do we even care about machine learning at first place? And what is automated machine learning? And how this new technology can help the modern data scientist to automate the workflow. First of all, I have an introduction. We'll move on to AutoML in action. We see specific examples for every task of machine learning building pipeline. Of course, we will see some tools and frameworks and what's the current state of the art. And the last, but not least, the most interesting part of this presentation, I think it's the AutoML case study, an end-to-end case study based on Google Cloud Platform. I'm using for this the Tables product. I think it's pretty new. It was still in beta some months ago. Okay. Let me move on to the introduction. First of all, let me define the machine learning term for anyone who isn't familiar with this term. So let's assume that we have a task to perform, such like a classification or regression or forecasting or anything. Before machine learning, we will write some handcrafted rules, some heuristics to perform this task. But after machine learning, the things are much better. We just learn the computer to learn this abstract function based on historical data, and that's the whole revolution of machine learning. We don't need to handcraft anything, but we let the computer to do all the work. So, who is the data scientist and who do all the work? As you can see here in the Venn diagram, data science is an interdisciplinary field. As you can see, of course, you need mathematics and statistics to be able to understand, to have a solid understanding of algorithms, etc. Of course, you need computer science to be able to write software for performing analysis, to be able to building machine learning pipelines. And of course, you need domain expertise. Without domain expertise, actually, you can't apply your skills in a meaningful way. You want to have impact in the business domain, and of course, you need domain expertise for that. So, let me start with the why. Why do we even care about automated machine learning? There are two main reasons for that. Of course, there is the data science case of AutoML, and as we will see later, there is the business case of AutoML. As a data scientist, I catch myself very often to repeat chunks of code between projects. You know, cross-validation is always cross-validation. Or if I want to try some ML algorithms like random forest or linear regression, these processes are pretty much dataset agnostic. You put a tabular dataset, you get the best model, etc. So these chunks of code are very repetitive and time-consuming. So of course, when a developer sees repetitive tasks, I can say that there is a lot of improvement here, a lot of space for automation. Of course, there is the business case of AutoML. Here actually is a bar chart from Kaggle surveys. This bar chart represents the data science barriers, the business barriers where data science applied in a business setup. As you can see here, many of these challenges can be solved if we automate things. For example, dirty data, lack of data science talent, etc., can be solved if we have a software to automate it, such repetitive and boring stuff. So, of course, the solution is automated machine learning for these problems. Gartner said at 2017 that more than 40% of data science tasks will be automated by 2020. So, we are here in 2020. Let's see where we are. AutoML in action here. Let's dive into the specifics of every step. As we can see here, I have a common flowchart of machine learning pipeline building. First of all, we need to define our problem and, of course, to get the data collection process. After there is a modeling, an extensive part, the modeling part. And after we found the best performing model, of course, we want to deploy it in production, to get reports, to build applications, etc. Automated machine learning models aims to automate the second part, the modeling part. The steps in modeling part are usually feature engineering, model selection, optimization, and evaluation, as you can see here. So let's do this step by step. Feature engineering. Feature engineering is a really broad topic because it contains data cleaning, feature extraction, feature selection, etc. Here I have a flowchart and infographic of how feature selection automated process will work. Of course, we have a new dataset and NML algorithm here. And after that, we rank features based on multiple ranking algorithms, train our machine learning model, and of course, measure the performance. We repeat this process multiple times for different subset of features until we get the best performing model with subset of features and get the reduced dataset at the end with not the complete feature dataset, but with a reduced, of course. The second part is the model selection part. As data scientist, I hear often someone claims that, XGBoost or LightGBM or even CatBoost, which is hot right now, will perform the best for sure because these algorithms have won many Kaggle competition. But this is actually not the case. We have not forget the bias variance trade-off. Actually, there is the no freelance theorem that states that there is no super algorithm. And because of that, we have to try and test every algorithm for our dataset because pretty simple algorithms may perform better. Here is an abstract description of how automated machine learning model selection will work. Of course, we have a new dataset. We extract dataset characteristics. And after that, we need to train and evaluate multiple machine learning models. So this is the time-consuming and repetitive step. Of course, after that, we rank models and get the top-performing model. It's pretty intuitive. And the last part is the hyperparameter optimization. This is, again, a highly repetitive and time-consuming task, which is not based in science, but mostly it is based on trial and error. So how this process works? We choose the hyperparameter choice, a set, an initial set of hyperparameters. We train our machine learning model. Of course, we measure performance and repeat this process again and again and again with different hyperparameter sets until we surpass a threshold or until convergence happens. And the output of this process is, of course, a tuned model. Up to now I have talked about mostly tabular dataset and traditional machine learning. What about deep learning? There is a lot of work here, of course. There is something called Neural Architecture Search, or NAS here. This is the process when we build neural networks or deep neural networks, we are not sure which structure will be the best performing structure, how many layers, how many nodes, what kind of activation functions, etc. And there is a whole scientific field which aims to automate these things, to choose for you the best structure for your neural network. So, okay, let's move on and see some tools and frameworks. Here I have a taxonomy of solution providers for automated machine learning tools. There are, of course, the tech giants here, Google's AutoML, okay, Amazon, of course, Microsoft Azure, there is here Oracle's autonomous database, IBM Watson, etc. There are a lot of startups in this field because there is a lot of room and many money go to this. DataRobot was the pioneering in this field, I think. H2O, AutoML, of course, AutoML from BigML, and many startups. And of course, there is a plethora of open source software for both Python and R. You can see here the Tpot. I think it's the Tpot, MLBox, feature tools actually is pretty good. I want to note two things here. Many of these tools aims to automate the whole machine learning building pipeline, while other tools, like feature tools, aims to specific tasks, like feature engineering or something like that. And one more note here is that some of these tools require from the user to write some code. Okay, you need to open your terminal and type something. But other tools removes this barrier again and offers a GUI, a graphical user interface, so non-technical users can use them pretty easily. Okay, so here I have an example from Microsoft Azure. I want you to show here that the code actually is the API is actually pretty simple. You don't need to define you need to define just 5 simple things. Of course, your task, classification here, your primary evaluation metric, of course, area under curve weighted here, experiment timeout minutes, how many minutes do you want to your machine learning algorithm search for solution? Of course, your training dataset, your label, number of cross validations repeats, and that's it. You hit start and go grab coffee or something. You are ready here. Okay, here's some more examples from H2O or Oracle's autonomous database or AutoScaLearn. For anyone who is familiar with SKLearn API, you can see here that the API is pretty consistent between these tools. You don't need to invest time to learn anything new. Of course, you define the classifier, you feed, you make predictions, that's it. Here the code actually is for R, for anyone who is familiar with R programming language. Okay, and here I have some examples of GUIs. This is the GUI example from H2O. It's pretty descriptive, I think. You can perform the complete machine learning pipeline here, just clicking buttons here and there. You can, of course, select everything you may want without even to write a single line of code and get a pretty analytical description of your model, of performance metric, etc. And here is another example of UI. Here is from DataRobot for a forecasting task. You can see here, we define as the target the sales, how many days in the future we want to predict, we hit start, and that's it. I think it's pretty simple, pretty intuitive, pretty interesting. Okay. So, okay, yes, now we have learned such a powerful tool, such an automated machine learning. It's like we have a virtual assistant in our office working with us, and now we can focus on more important things of the work. Okay. So, let's move on to the last part, the case study part. For this, I use the Google Cloud Platform. Everyone here knows the Google Cloud Platform. I have focused in artificial intelligence menu. Google's actually offer a variety of products or solutions here. We can see data labeling, natural language processing, recommendations AI, tables, translation, vision, video intelligence. Google offers a variety of tools for almost any data structure or data type. I work for this presentation in tables product, actually, because I have a tabular data set. Here, there is the data source for me. I choose the Numerai dataset. Okay, what is Numerai for anyone who isn't familiar with this? Numerai actually is a crowdsourced hedge fund based in San Francisco. And actually, they host a weekly tournament when they make available stock market data every week. Users deploy their predictions based on some machine learning models. And depending on the performance of their prediction, they get paid. It's a pretty interesting business model for Numerai. So I choose their dataset. As you can see here, the tables product are built based on a 5-step pipeline. Of course, we have to import our dataset, train, get a glimpse of our models, evaluate, test, and use. That's it. 5 simple steps, or point and clicking, 0 code needed, guys. I'm telling you for sure. So here is a screenshot from the Numerai dataset. As you can see, the Numerai dataset, if you look closely, is obfuscated. That means that we don't actually know what every feature means because of IP restrictions. So it just says here feature intelligence N, feature 1, feature intelligence 2, etc. So we upload our dataset or BigQuery or storage. The next step is to define our train parameters. Of course, here we define the target column and we define some additional parameters before the training process. These additional parameters are the data split, of course, if we want to perform a holdout evaluation or a cross-validation or anything like that. Of course, there is the weight column, the model name, the training budget. Here, the training budget is the most important parameter because if you make any mistake here, you will be pay a lot in Google. How many hours Google try to find the optimal solution, the best machine learning model for you, for your data set. Of course, which features will be used. And finally, the summary of your model. If you can look here, the model type will be a multi-class classification model. Actually, this was selected automated by Google because they find that the target column has 5 unique values. So 5 unique values can be solved as multi-class classification model. Of course, this is something can be changed. And after that, we hit start. And after a couple of hours, we have our model trained. We have many models, but the best performing model are here. We can, of course, evaluate this model. So we can see many of evaluation metrics depending on the task. Here we can see FNR score, precision, true positive rate, true negative rate, etc. Of course, we can see some things like, like feature importance or confusion matrix, etc. And the last part, okay, we have found the best performing model. We want to deploy our model in production. Of course, there is three options here. The batch prediction. If we had some data stored in Google Storage or BigQuery, we can predict on them. There is, of course, the online prediction based on an API or something. And the final option is to export our model to a Docker container. So we can use this model actually on our local PC or to any other environment outside of GCP. This is pretty interesting, I think. So, some closing remarks about automated machine learning. Of course, there are many advantages, as we can say by now. The fast experimentation, as I said, the AutoML is just another productivity tool. It's just a virtual assistant. You do the manual and repetitive and boring work for you. And there is an important advantage here, the democratization of machine learning, as I already said again, okay. AutoML removes the barrier and non-technical users can use machine learning without even understanding machine learning. Of course, there are a lot of disadvantages and a lot of space for improvement yet, because these solutions are not fully automated, cannot offer customized solutions because they are so general. Okay, of course, there aren't human competitive yet. In Kaggle, I haven't seen any automated machine learning solution win yet. No RL applications and lack of domain knowledge, of course. We haven't the way to put domain knowledge in AutoML yet, just yet. Okay, so the conclusion here is that in your next AI or data science interview, of course, you can, if you know any of these tools, you can claim that you are a machine learning expert or machine learning hero. Okay, without even understanding the linear regression. Okay, I think this is just a joke. This is not the case here, of course. As I said, the AutoML is just a tool, a virtual assistant to free up your time and enables you to focus on what actually matters in business matter and to do your job best. Okay, this is the contact information. Thank you very much for your attention. If we have any question, Elias.
Okay, thank you very much, Panagiotis.
Thank you very much, Elias.
We have time for questions, but I don't think there are any questions right here. Maybe you have to join the Slack and answer there.
Okay, I'm going to
have used AutoML. It was really fascinating because it did everything for me. I just pressed the button. I went for my training, returned after 4 hours because I was going for beers. And then my model was ready. I gave it to the client and he was very happy.
Yeah, I think AutoML is pretty fascinating technology, yes.
The Slack and talk with
Okay. I'm going to Slack.
We have a 5 minutes break until Michalis will be ready for our second round of gaming. Okay, Michalis is here and he's ready for the second game. We changed the time so you will have time to see the question and answer. Michali, can you share your screen, please? We are having problem again, technical problem, of course. It's a live event, everything can happen. We are working on it. Sorry for the inconvenience.
Hello, can you hear me now?
Mihaly, whenever you are ready, people are
Hello.
waiting. And we are sorry, but we don't know the sign language. Although a few days ago, there was a great article from Google that they have already built a mobile application where you can move and do sign code and it will translate whatever.
Hello.
You have more time to see my red blood curly long hairs. Thank you for your understanding. No, we cannot provide PIN because we cannot have the connection with Michalis. And Michalis must have a connection with Kahoot.
Hello. Can you see or hear me? I don't get a response from the platform. Trying to share my screen. Sorry for. Okay. Let's try again. Share screen. Yeah. We have it. Okay. People started joining.
Unfortunately, we're not going to have the second game due to problems with the connection, but we'll continue with our next speaker. His name is Fotios. He's working for Deloitte Greece here in Thessaloniki, my hometown. And he's going to talk about Kubernetes. Kubernetes is the solution to the sentence that everybody has already said it at least once, but it's working on my machine. So, Fotis, the stage is yours.
Hello, everybody. Just 1 second to share my screen. So, hi, my name is Fotios Tragopoulos. I'm a cloud enthusiast working with cloud technologies for the last 3 years. I come from a full stack background and have worked with several technologies and platforms. I'm in the industry since 2005 and have worked as an industrial programmer, iOS and OS X developer, and currently as a cloud engineer. I participated in several open source communities and contributed to great projects like DuckDuckGo and Odoo ERP. I also authored a few program guides. Currently, I live in Greece and working for Deloitte as a senior consultant. In this slide, you can find my email as well as my LinkedIn and GitHub username. Please feel free to connect with me. Programming is so much better when you do it with company. We will start today with an introduction to containers and Kubernetes, and then we will see a few things about Google Cloud, their ecosystem and offering. We will delve into Kubernetes to see what it consists of and how it works. Finally, we will see several Kubernetes-based services that exist in Google Cloud. These are Cloud Run, Kubernetes Engine, App Engine, and Cloud Functions. So let's start with a few things about containers and Kubernetes. What is a container? A container is a standard unit of software that packages up code and all its dependencies so the application runs quickly and reliably from one computing environment to another. A Docker container image is a lightweight standalone executable package of software that includes everything needed to run an application: code, runtime, system tools, system libraries, and settings. I'm sorry, I think that I need to share my screen again. Okay. Comparing containers and virtual machines, containers are an abstraction at the app layer that packages code and dependencies together. Multiple containers can run on the same machine and share the operating system kernel with other containers, each running as isolated processes in user space. Containers take up less space than virtual machines. Images are typically tens of megabytes in size, can handle more applications, and require, I'm sorry about that. Yes, and require fewer virtual machines and operating systems. So virtual machines are an abstraction of physical hardware, turning one server into many servers. The hypervisor allows multiple virtual machines to run on a single machine. Each virtual machine includes a full copy of an operating system, the application, necessary binaries and libraries, taking up tens of gigabytes. Virtual machines can also be slow to boot. Containers and virtual machines used together provided a great deal of flexibility in deploying and managing applications. The concept of containers was started way back in 1979 with Unix chroot. It's a Unix operating system call for changing the root directory of a process and its children to a new location in the file system, which is only visible to a given process. The idea of this feature is to provide an isolated disk space for its process. Later, in 1982, this was added to BSD. FreeBSD jails is one of the early container technologies for FreeBSD in year 2000. It is an operating system call similar to chroot, but included additional process sandboxing features for isolating the file system, users, networking, etc. As a result, it could provide the means of assigning an IP address for each jail, custom software installations and configurations, etc. Linux vServer is another jail mechanism that can be used to securely partition resources on a computer system. File systems, CPU time, network addresses, and memory. Each partition is called a security context, and the virtualized system within it is called a virtual private server. Solaris containers were introduced for 80x86 and Spark systems. First released publicly in February 2004 in build 51 beta for Solaris 10, and subsequently in the first full release of Solaris 10, 2005. A Solaris container is a combination of system resource controls and the boundary separation provided by zones. Zones act as completely isolated virtual servers with a single operating system instance. OpenVZ is similar to Solaris containers and makes use of a part Linux kernel for providing virtualization, isolation, resource management, and checkpointing. Each OpenVZ container has an isolated file system, users and user groups, a process tree, network, devices, and IPC objects. Process containers was implemented at Google in 2006 for limiting, accounting, and isolating resource usage, CPU, memory, disk input-output, network, etc., of a collection of processes. Later on, it was renamed to control groups to avoid the confusion of the multiple meanings of the term container in the Linux kernel context, and merged to the Linux kernel 2624. This shows how early Google was involved in a container technology and how they have contributed. As explained above, control groups, aka C groups, were implemented by Google and added to the Linux kernel in 2007. LXC stands for Linux Containers, and it's the first, most complete implementation of Linux Container Manager. It was implemented using C groups and Linux namespaces. LXC was delivered in liblxc library and provided language bindings for the API in Python 3, Python 2, Lua, Go, Ruby, and Haskell. In contrast to other container technologies, LXC works on vanilla Linux kernel without requiring any patches. Today, LXC project is sponsored by Canonical Ltd. Warden was implemented by Cloud Foundry in 2011 by using LXC at the initial stage and later on replaced with their own implementation. Unlike LXC, Warden is not tightly coupled to Linux. Rather, it can work on any operating system that can provide ways of isolating environments. It runs as a daemon and provides an API for managing the containers. LMCTFY, it stands for Let Me Contain That For You. It is the open source version of Google's container stack, which provides Linux application containers. Google started this project with the intention of providing guaranteed performance, high resource utilization, shared resources, overcommitment, and near zero overhead with containers. The C-Advisor tool used by Kubernetes today was started as a result of LMC-TFY project. The initial release of it was made in October 2013, and in the year 2015, Google decided to contribute core LMC-TFY concepts and abstractions to libcontainer. As a result, now no active development is done. The libcontainer project was initially started by Docker, and now it has been moved to Open Container Foundation. Docker is the most popular and widely used container management system. It was developed as an internal project at a platform as a service company called .cloud, and later renamed Docker. Similar to Warden, Docker also used LXC at initial stages and later replaced LXC with its own library called libcontainer. Unlike any other container platform, Docker introduced an entire ecosystem for managing containers. This includes a highly efficient layered container image model, a global and local container registries, a clean REST API, a CLI, etc. Docker also implemented a container cluster management solution called Docker Swarm. Docker Compose is also a tool for defining and running multi-container Docker applications. What is Kubernetes? Kubernetes is an open source container orchestration system for automating computer applications, deployment, scaling, and management. It was originally designed by Google and is now maintained by the Cloud Native Computing Foundation. It aims to provide a platform for automating deployment, scaling, and operations of application containers across clusters of hosts. It works with a range of container tools, including Docker. So what it can do? Service discovery and load balancing. It can expose a container using the DNS name or using their own IP address. If traffic to a container is high, Kubernetes is able to load balance and distribute the network traffic so that the deployment is stable. Storage orchestration allows you to automatically mount a storage system of your choice, such as local storages, public cloud providers, and more. Automated rollouts and rollbacks. You can describe the desired state for your deployed containers using Kubernetes, and it can change the actual state to the desired state at a control rate. For example, you can automate Kubernetes to create new containers for your deployment, remove existing containers, and adopt all the resources to the new containers. Automatic bin packing. You provide Kubernetes with a cluster of nodes that it can use to run containerized tasks. You tell Kubernetes how much CPU and memory RAM each container needs. Kubernetes can fit containers onto your nodes to make the best use of your resources. Self-healing. Kubernetes restarts containers that fail, replaces containers, kills containers that don't respond to your user-defined health check, and doesn't advertise them to clients until they are ready to serve. Secret and configuration management. Kubernetes lets you store and manage sensitive information such as passwords, zero authentication tokens, and SSH keys. You can deploy and update secrets and application configuration without rebuilding your container images and without exposing secrets in your stack configuration. Google introduced the Borg system in 2003. It started off as a small-scale project with about 3-4 people initially in collaboration with a new version of Google's new search engine. Borg was a large-scale internal cluster management system which ran hundreds of thousands of jobs from many thousands of different applications across many clusters, each with up to tens of thousands of machines. Following Borg, Google introduced the Omega cluster management system in 2013. Omega is a flexible, scalable scheduler for large compute clusters. In 2014, Google introduced Kubernetes as an open source version of Borg. We have the initial release, first GitHub commit for Kubernetes. The same year, Microsoft, Red Hat, IBM, Docker, and many more joins the Kubernetes community. On 2015, Kubernetes version 1 gets released. Along with the release, Google partnered with the Linux Foundation to form the Cloud Native Computing Foundation, the CNFC. So the CNFC aims to build sustainable ecosystems and to foster community around a constellation of high-quality projects that orchestrate containers as part of microservices architecture. The same year, more companies joined the ecosystem like Days, OpenShift, Highway, and Gondor. On 2016, we have the first release of Helm, the package manager of Kubernetes, and the Minikube, a tool that makes it easy to run Kubernetes locally. Also in September 29 of 2016, we have the largest Kubernetes deployment of on Google Container Engine ever, which is Pokemon Go. At the end of the year, with the release of Kubernetes 1.5, Windows Server support comes to Kubernetes. 2017 was the year of enterprise adoption and support. GitHub runs on Kubernetes. All web and API requests are served by containers running in Kubernetes clusters deployed on Metal Cloud. The same year, Oracle joined the Cloud Native Computing Foundation as a platinum member. Docker fully embraces Kubernetes. Developers and operators can build apps with Docker and seamlessly test and deploy. And deploy them using either Swarm or Kubernetes. Microsoft announced the preview of AKS and AWS announced Elastic Container Service for Kubernetes. A few words for Google Cloud. For the past 16 years, Google has been building the world's fastest, most powerful cloud infrastructure on the planet. It operates already in 24 cloud regions and will soon be in another 9. When you look at Google Cloud, you'll see that it's actually part of a much larger ecosystem. This ecosystem consists of open source software, providers, partners, developers, third-party software, and other cloud providers. Also, Google is a very strong supporter of open source software. A few things about Google Cloud's, about GCP's shared responsibility model. With blue color, the stack level of the user's responsibility, and with the orange, the providers. Infrastructure as a service. It provides only a base infrastructure, virtual machine, software-defined network, storage attached. The end user have to configure and manage platform and environment. Deploy applications on it. Container as a service is a form of container-based virtualization in which container engines, orchestration, and the underlying compute resources are delivered to users as a service from a cloud provider. Platform as a service. It provides a platform allowing end user to develop, run, and manage applications without the complexity of building and maintaining the infrastructure. Function as a service, it provides a platform allowing customers to develop, run, and manage application functionalities without the complexity of building and maintaining the infrastructure. Of course, Google provides many other service types like software as a service, like G Suite, or backend as a service, like Firebase. Google Cloud provides services for compute storage and databases, networking, big data, developer tools, identity and security, Internet of Things, cloud AI, management tools, and data transfer. Google Cloud Platform is not the only platform that exists in order to use Google Cloud services, containers, or Kubernetes. Let's have a look now at how Kubernetes works and its core components. When you deploy Kubernetes, you get a cluster. A Kubernetes cluster consists of a cluster master and one or more nodes, which are the workers of the cluster. The cluster master controls the cluster and can be replicated and distributed for high availability and fault tolerance. The cluster master manages services provided by Kubernetes, such as the Kubernetes API, controllers, and schedulers, users can interact with a cluster using the kubectl commands. Nodes are primarily controlled by the cluster master, but some commands can be run manually. The nodes run an agent called kubelet, which is the service that communicates with the cluster master. Pods are single instances of a running process in a cluster that contain at least one container. Multiple containers are used when they need to share resources. Pods use shared networking and storage across containers. Each pod gets a unique IP and set of ports. Containers connect to a port. Multiple containers in a pod connect to different ports and can talk to each other on localhost. Pods are considered ephemeral. They are expected to terminate if a pod is unhealthy, stuck, or crashing. The controller manages scaling and health monitoring. Deployments are sets of identical pods. The members of the set may change as some pods are terminated and others are started, but they are all running in the same app. Replica set is a controller used by a deployment that ensures the correct number of identical pods are running. Replica sets are also used to update and delete pods. Services are objects that provide API endpoints with a stable IP address that allow applications to discover pods running a particular app. Services update when changes are made to pods, so they maintain an up-to-date list of pods running an application. A stateful set allows to have a single pod respond to all calls for a client during a single session. It is assigning a unique identifier to pods, so Kubernetes can keep track which pod is used by which client. It is used when an application needs a unique network or persistent storage. Jobs are workloads. They create pods and run them until the application completes. Job specifications are specified in a configuration file and include specifications about the container to use and what command to run. Persistent volumes provide an API for users and administrators that abstracts details of how storage is provided from how it is consumed. Persistent volumes is a piece of storage in the cluster that has been provisioned by an administrator or dynamically provisioned using storage classes. Cloud Run. Let's define first what is serverless computing. It is a paradigm shift in application development that enables developers to focus on writing code without worrying about infrastructure. It offers a variety of benefits over traditional computing, including zero server management, no upfront provisioning, auto-scaling, and paying only for the resources used. These advantages make serverless ideal for use cases like stateless HTTP applications, web, mobile, Internet of Things backends, batch and stream data processing, chatbots, and more. Container as a service has two services, which are Cloud Run and Kubernetes Engine. Cloud Run is a managed compute platform that enables you to run stateless containers that are invocable via web requests or PubSub events. Cloud Run is serverless. It abstracts away all infrastructure management so you can focus on your code. It is built from Knative, letting you choose to run your containers either fully managed with Cloud Run in your Google Kubernetes Engine cluster or in workloads on premises with Cloud Run for Anthos. Cloud Run is ideal serverless platform for stateless containerized microservices that don't require Kubernetes features like namespaces, co-location of containers in pods, or node allocation and management. The managed serverless compute platform, Cloud Run, provides a number of features like easy deployment of microservices. Uncontainerized microservice can be deployed with a single command without requiring any additional service-specific configuration. Each microservice is implemented as a Docker image, Cloud Run's unit of deployment. A microservice deployed into managed Cloud Run scales automatically based on the number of incoming requests. without having to configure or manage a full-fledged Kubernetes cluster. Managed Cloud Run scales to 0 if there are no requests. Cloud Run is based on containers, so you can write code in any language, using any binary and framework. It comes with a simple command line and the user interface and integrates with Cloud Code and Cloud Build for CI/CD. Of course, it supports strict container isolation, custom domains, and it provides an out-of-the-box HTTPS endpoint with TLS terminations self-handled. Kubernetes Engine. Kubernetes Engine is a secured and managed Kubernetes service with auto-scaling and multi-cluster support. It starts easily with many single-click options. It offers auto-repair and auto-upgrade, vulnerability scanning, and data encryption. When it comes to managed Kubernetes services, Google Kubernetes Engine is a great choice if you are looking for a container orchestration platform that offers advanced scalability and configuration flexibility. GKE gives you complete control over every aspect of container orchestration, from networking to storage to how you set up observability, in addition to supporting stateful applications. However, if your application does not need that level of cluster configuration and monitoring, then fully managed Cloud Run might be the right solution. Some other considerable features of Kubernetes Engine are control access in the cluster with your Google accounts and role permissions, reserve an IP address range for your cluster, allowing your cluster IPs to coexist with private network IPs via Google Cloud VPN, one-click configurations for cloud logging and cloud monitoring, fully managed clusters and automatic updates with the latest release version of Kubernetes. When auto-repair is enabled, if a node fails a health check, Kubernetes Engine initiates a repair process for that node. Resource limits on CPU and memory per container. It provides a private container registry for your Docker images. Cloud Console offers dashboards for your project's clusters and their resources. You can use these dashboards to view, inspect, manage, and delete resources in your clusters. It offers load balancing to distribute incoming requests across multiple regions, and it supports both Linux nodes and Windows servers. App Engine. Each Google Cloud project can contain one App Engine application. You can scale up to 7 billion requests per day and automatically scale down when traffic subsides. App Engine is well suited for web and mobile applications and supports most popular programming languages like Node.js, Java, Ruby, C#, Go, Python, PHP, or bring your own language runtime. Custom runtimes allow you to bring any library framework to App Engine by supplying a Docker container. It gives you the option to choose the storage you need, a traditional MySQL database using Cloud SQL, schemaless NoSQL data store, or object storage using Cloud Storage. It also offers application diagnostics and tools to diagnose and fix bugs with cloud monitoring, cloud logging, cloud debugger, and error reporting. It allows to host different versions of your application and create development, test, staging, and production environments. It gives you the option to route incoming requests to different application versions and do incremental feature rollouts. You can also define access rules with App Engine, Firewall, and manage SSL TLS certificates. App Engine applications consists of an application, a service, a version, and an instance. An application has at least one service, which is the code executed in the App Engine environment. Under the service, there is a versioning system that holds all the versions of your application. When a version executes, it creates an instance of the app. Services are typically structured to perform a single function, and complex applications are made of several microservices. Because we mentioned the App Engine's use of Docker containers, you may be wondering how App Engine compares to Kubernetes Engine. Here is a side-by-side comparison of App Engine with Kubernetes Engine. App Engine comes in two editions, flexible and standard. The standard edition is for people who want the service to take maximum control of their application's deployment and scaling. Kubernetes Engine, on the other hand, gives the application owner the full flexibility of Kubernetes. App Engine Flexible is in between. Also, App Engine environment treats containers as a means to an end, but for Kubernetes Engine, containers are a fundamental organizing principle. Finally, let's have a look at Cloud Functions. Google Cloud Functions is a serverless execution environment for building and connecting cloud services. It is a lightweight computing option for event-driven processing. It supports Node.js, Python, Go, and Java. The functions execute in a secure, isolated environment, and they are code-independent and stateless. With Cloud Functions, you write simple single-purpose functions that are attached to events emitted from your cloud infrastructure and services. Cloud Functions lets you treat all Google and third-party cloud services as building blocks. You can connect and extend them with code and rapidly move from concept to production with end-to-end solutions and complex workflows. Further, they integrate with third-party services that offer webhook integrations to quickly extend your application with powerful capabilities. Cloud Functions abstracts away all the underlying infrastructure and scales automatically. An event is an action in Google Cloud, such as a file upload to the cloud storage. GCP supports events in cloud storage, upload, delete, or archive. Cloud PubSub, it has an event for publishing a message. HTTP by calling a specific function, Firebase. In the Firebase DB by using triggers, and logging by forwarding logs to a PubSub topic. For every for every cloud function, you can define a trigger, and triggers are associated with functions. Thank you very much for joining me. I hope you enjoyed this presentation and now have an idea of where to start if you ever need to use Kubernetes in GCP. You can also find my article, Google Cloud Platform Handbook for Enthusiasts, on LinkedIn, where you can have a broader look at GCP services. So that's all from me. I don't know, Elias, if we have time for discussion, for some questions.
Thank you very much, Fotis. It was really insightful, everything you told us about Kubernetes and Cloud Run and all that technologies. We don't have any question right here, right now. Maybe you have questions waiting for you on Slack.
Mm-hmm. Great.
Okay, thank you very much.
Thank you all, and keep safe.
Okay, have a great day. Bye.
Bye-bye.
So our next speaker is here. Let me check if Ashita is ready. Okay, Ashita is gonna tell us about Flutter. Flutter is a programming language where you write once and it plays on Android, iOS, web application, everything, anything. So, Ashita, the stage is yours.
Hello, can you hear me? Can you hear me? Can you hear me? Hello? Yeah. So just give me a minute and I'll start the session. Let me know if you can see the screen. Yeah. So let's begin with the talk. So hi everyone, I am Ashita, a consultant by profession and a product person at heart. And I'm also the creator of Flutter Gems. And today in this talk, we are going to navigate the Flutter ecosystem and starting from package discovery to the publishing of a package and beyond. So before we delve into today's talk, let me give you a quick overview of Flutter for people who are new to this technology. So Flutter is Google's cross-platform UI toolkit. With a single source code, you can deploy your apps across mobile, web, and desktop. For mobile, you can deploy your apps across both iOS and Android App Store. For your web apps, which you build on using Flutter, they will be seamlessly accessible via all the popular web browsers such as Edge, Safari, Chrome, Firefox, and Opera. And for desktop, you can build your apps for Windows, macOS, Linux, and Chrome OS. Now, what happens is when you use a single code base to deploy your apps across desktop, mobile, as well as web, it results in a faster development cycle. Not only this, Flutter also provides hot reload, which is a very useful feature while debugging and helps increase developers' efficiency. With its vast library of widgets that it has inbuilt, it helps us make expressive and beautiful UIs. Now, unlike other cross-platform UI toolkits that are available, Flutter directly compiles its code into native code, which results in a very high performance. And last but not the least, Flutter is based on a very easy to learn Dart programming language. Now, Dart is also a programming language which was developed by Google again. So Flutter is relatively young. It's been just 3 years since the first alpha release of Flutter. And in such a short span of time, Flutter has completely taken the world by storm. Just in Google Play Store, in April 2020, there were around 50,000 apps on the store, whereas in the next 3 months, that number rose to an overwhelming 90,000. Flutter has become a preferred choice for startups, small medium enterprises, and large-scale businesses alike. To show you the power and scalability of Flutter, let's delve into some real-world examples. Dream 11. So this is an app which is basically India's biggest fantasy sports platform, and it is currently sponsoring India's biggest sporting event called the IPL. So Dream 11 has been entirely built on Flutter, and it boasts of more than 100 million users. so you can realize how powerful Flutter is. Second, Google Pay. You must have heard recently Google Pay completely migrated to Flutter. Now, what made them choose Flutter? The fact that you can write a code once, deploy it both on iOS and Android, giving your customer a seamless experience across both the interfaces. A JIT compiler with hot reload significantly increases the developer's efficiency, and it also enables a very rapid iteration on your UI itself. And an ahead of time compilation, which ensures that there is a high performance deployment. Now let's move into smart apps category, Philips Hue. Now, what made a company like Philips choose Flutter for their development? So, well, the reason they chose Flutter was just because of the sheer number of packages that are available that provide functionality for Wi-Fi, BLE, Bluetooth, NFC, and beacon, which makes Flutter a really useful framework for building IoT and smart home apps. So now let's understand. Flutter is much more than just an engine, a set of widgets, and some tools. It includes a large ecosystem of packages which can add functionality to your apps, which is much beyond what comes out of the box. Just Dart and Flutter have more than 12,000 plus packages on PubDev. And maneuvering this vast landscape to find the right package for your requirement is often a daunting task. So to understand this better, let's undertake a developer's journey. So how does the developer start? He usually starts by gathering requirement. And as we all know, a picture is worth more than 1,000 words. So usually the requirement, he tries to make a crude mock-up or a wireframe of the requirement. Now that can be done using a pen and a paper like shown in the image, or you could also use some tools like say Origami Studio, etc. or Figma to actually build it on a computer. So the first thing that you do is make a crude mockup. The next thing that you do is you try to map your crude mockup to material design components. You will go to material design website and you will try to figure out what is it that you want. Is it an app bar? Is it a backdrop? Or is it a floating action button, a button bar? And you will try to figure out the components. But let's say, what if your product manager comes to you and says that this is what he is looking for? He wants a pack of cards with text and images on it, similar to Pinterest. How will you go about defining your requirements in such a case? Or say you are given this requirement where he says that he wants a slider, and on one side of a moving slider, on one side of the image, you need to show what is the past, and on the right side, present. Then begins what we call the hunt to express your required widget in words. So let's take the previous example. You see that there is a moving slider. You have an image on both the sides. So what will be your first instinct to search? You will go on PubDev, which contains all the Dart and Flutter packages, and you will type image. You will try to search with the first main keyword that you have, image. So these are the packages that you get. If you read through it, it is mostly about saving images, downloading images, supporting placeholders. Clearly not what you are looking for. The next thing that you would do is you go and put image slider. Now again, the options that are shown is more in the range of a carousel. So if you see, even image slider will let you slide across images. Again, not what you are looking for. Or a carousel pro, something similar to a splash screen that you get in the beginning when you download an app. So what do you do in such a case? So before understanding why we couldn't get our results, let's take a step back and understand how search at PubDev works. So search at PubDev is completely text driven. The text that you type on the search bar, they have an internal algorithm, and basis the search relevance, your packages are displayed. Now there are individual package scores. These are based on 3 parameters. First is likes, which shows the number of developers that have liked a particular package. Second is popularity, which shows the number of developers that are actually using your package. And third is pub points. Pub points is a more of a measure, quality check, you can say, and it is based on various dimensions such as documentation, code style, platform support, and maintainability. So you didn't get what you were looking for on PubDev. What is the next obvious thing that a lot of developers will do? They will go on various forums, try to post their requirements via image, try to explain what they are looking for, and try to get help from the community. And this is in itself a tedious process. You might not get what you are looking for, or the cycle to get your reply using this is pretty long. So what if I told you that there is a visual discovery platform which can aid you in your search? Because as we all know that a picture is worth more than 1,000 words. So that's where Flutter Gems comes to our rescue. Flutter Gems is a Flutter package landscape guide which comprises 1,500 plus neatly categorized packages based on functionality. As you can see, you have a lot of categories and more. So to check out the platform, you must go and check out fluttergems.dev. So let's go to our first problem statement that we were trying to solve. A pack of cards with some text and images. So if you see closely, you will see that there are a lot of grids in the image, and there is a category called grid on Flutter Gems, so which has 4 packages. So if you go and view that category, you will see that there are 4 packages that are displayed. One is the Flutter staggered grid view, one is the drag select grid view, one is the Flutter layout grid, and one is the waterfall flow. So just by visualizing the images, you can say that waterfall flow was the exact package that you were looking for. Now, coming down to waterfall flow via PubDev was very, very difficult. The reason being the name was not so intuitive given your requirements. You have a staggered grid or you have a pack of cards, and coming down to the name waterfall flow was very, very difficult for someone. And also, the individual package score might not be very high. As you can see in this case, it just has 15 likes, which is one of the lowest in the grid itself. And the reason being, your requirements might not match the requirements of a lot of other product developers out there, which is why its popularity score or likes might just fall down. But when you use Flutter Gems, you can easily, within 10 to 15 seconds of a glance, just get the package that you were looking for. Coming to our second example of the image slider, there is a category called image on Flutter Gems. And if you go into it, you will see that there is this package called before after, which clearly shows the slider and the before and the after part of the image. So if you see your requirement, this is the exact package that you are looking for. Now again, image slider, the name image slider and the required package name is before after. So coming down to the name before after was again very difficult via PubDev. But if you use Flutter Gems, you can easily visualize it in very less time. So now let's understand the product development process as such. It is not a straightforward linear process where a product manager is going to come and give you requirements and you as a developer will just develop it. It is not a linear process. Often product managers themselves are not fully aware of the technical capabilities of the platform that is being used. That is where you, as a product developer, can pitch in. Say you are glancing through Flutter gems and you realize that there is a new UI category that has come up, neumorphic UI. You can glance through it and you can actually take a call that maybe your app, if it is redesigned or if you can use some components of this UI to improve the experience of the user, you can go and let that know to your product manager and you can actually contribute to the product development process as such. Or say a floating action button. This is one of the most commonly used widgets across all apps. And there are a lot of variants available. Now, again, as a product manager, one might not be aware of all the variants that Flutter is capable of. And that's where when you actually glance through Flutter gems, you will be able to see that there are a lot of variants. Now, some of the variants might actually be more suited to your need compared to the one that you are actually using. You can again go and pitch in, and that's where you can actually contribute to the entire product development process. So now let's say that you come across a scenario where you couldn't find the package that you were looking for, neither on PubDev nor on Flutter gems. So how do you go about in such a case? So what should you do in such a case? The important thing is, in such a case, you must try to find the package that most resembles your requirement on Flutter gems, on PubDev, and then you need to select that package. You need to suggest enhancements by raising an issue, and you need to send across your pull request to the project owner post discussion. It is very important to understand in this scenario that you must only fork the project as a last resort, because the moment you fork your project, the entire responsibility of maintaining the fork project comes on you, which is a very big responsibility. Now let's say that you even couldn't find a package that closely resembled your need. In that case, you might have to just go ahead and write a full package by yourself and release it. So let's try to understand how you go about releasing your package. So the first important thing for a package is documentation. Your README is the most important thing for your adoptability of the package. You need to literally treat it like your Tinder profile. A good README can your README can actually get you either a left swipe or a right swipe from your user. A well-documented API is a must. And it's very important to include small micro examples rather than large monolith ones. What happens in small micro examples is you can actually highlight every feature of your package. And often as a user, I might not be looking to use all the features that your package is providing, but say only a few of them. Grasping the features that I require from a large monolith example is very, very difficult compared to small micro examples. Secondly, you need to spread the word about your package. So there's a very active Flutter community on Reddit called Flutter Dev. You should definitely go and announce your package there. You need to publish need plus use case stories on Flutter community at Medium. And you need to reach out to your local Flutter chapter so that they can spread the word on Twitter and meetups. And last but not the least, go ahead and submit your package on Flutter Gems so that people, while visually browsing it, can actually see whether it fits their requirements or not. Now coming to the next step. Releasing the package is actually only half the work done. Maintaining the package is also equally important. So testing. Testing is a very key important of package maintenance. You need to do unit testing, where you test a single function, method, or class. You need to do widget testing or component testing, where you actually test a single widget. You need to do integration testing, where you test a complete app or a large part of the app. And you can actually automate all this using various CI/CD tools available, like which are free for open source projects like Travis CI. It is also very important to set a release frequency for your app or for your package that you are releasing. For every major release, like you need to set a frequency for every major release, and it is advised that major release every quarter to ensure that you are accommodating all the changes that Flutter itself is making. And you need to update your changelog.md with each new release to list notable changes. Now you can have various notable changes, like you might want to add new features, you might want to change an existing functionality based on some user feedback or your own requirement. You might want to deprecate soon to be removed features. You might want to actually remove some features itself, fixing all the bugs, and obviously security updates to combat vulnerabilities. It is just not important to actually release a package and maintain it, but it is also very important to collaborate with the community on the same. You must always try to become a benevolent dictator for life. So it is very important that you add a contributing.md file in your repository and set guidelines for repository contributors so that people can come ahead and actually contribute. You also need to be active and respond to all issues and pull requests. And as I said, you must become a benevolent dictator for life and let the community shape the future of the package. So if you know of a great package that you have built, or you know of some other package that you are using, you should surely go ahead and click on that contribute button on Flutter Gems so that everyone in the community can know about the package. So before closing the session, I would just like to show the website of Flutter Gems, which you can access. So as you can
Thank you
see,
very
this
much.
is the Flutter. Yeah. You're saying something, Elias? Okay, so as you can see, this is the Flutter Gems website, and it has 1500 plus packages which are neatly curated based on functionality. You can find a lot of categories here for user onboarding, like splash screen, which is a very common feature used in apps. Functionality, say you have to add payments to your app, you have to do state management, which is a very hot topic in Flutter always, and machine learning or game development. In case of UI, which is one of the uh, key strengths of Flutter, as I would say, you can see we have widget library, UI framework, settings UI, new interesting UI concepts, responsive UI. You have multimedia camera placeholders. You have components of each and every component of the app which you want to make. You have various scrollables which you can see, various user input like which you want, which you need while taking input from the user, pickers, typography, network, dev tools, storage, file formats, helper utilities. And there is also this category called ecosystem, where if you want to stick to a same ecosystem, you can actually just have a glance of all the packages that are available within a given ecosystem. So if there are any questions, let me know.
Thank you very much for joining, Ashita. It was a
Yeah,
really
thanks a
pleasure.
lot.
As Talking wrote, one to rule them all. You have a lot of questions waiting for you, not here, but
Yeah.
on Slack channel. Please go to your dedicated room. People are waiting
Sure.
for you there. Okay, thank you
Yeah.
for coming.
Thanks a lot. Bye.
Bye. Our last but not least speaker is Sophie. I'm really glad that she's here, and I'm really thankful because she had an awful time this night at her house. And as you can see, we have the same hair color. Hello, Sophie. Nice to meet you. And the stage is yours.
Can you hear me better now? Oh no. Can you hear me now? Yay. Okay. Right. I'm going to try and share my talk, but I can't. I can't see if this works. Okay. Right. So, hi everyone. Thank you for having me. Sorry about the technical problems there. My name is Sophie. I'm going to talk to you about the skills that I learned during my time as an English teacher that have made me a better developer. If you can't see my slides, please let me know on Twitter. Right, that was a brilliant start. I'm a senior web engineer at Monzo Bank in the UK, and I lead the web discipline, the web engineering discipline, along with my colleague Dylan. I also lead a choir at Monzo as well, which unfortunately we haven't been able to do for quite a long time this year, but it's good fun. You can contact me on Twitter. My username is typeerror with 2 underscores, or I have a website where I write things occasionally, or you can email me at sophie@localghost.dev. So, I studied linguistics at university. I think that's so interesting. And I graduated in 2013 with no idea what I was going to do with my life, basically. I ended up training as an English teacher and studying and learning English as teaching English as a foreign language until eventually I did a master's in computer science and became a software developer. But once I started a full-time job in tech, I was really amazed at how transferable my teaching skills were. So into it, like before 2020, like when we used to go to events in real life, I did a lot of mentoring with kids and adults learning to code. And those skills really came in useful. And further down the line now, I'm mentoring junior developers on my team, and I'm writing documentation for my organization. And once again, I'm putting those teaching skills to good use. And as developers, it is vital that we have good communication skills. It's not just enough to put our heads down and write code all day. We need to be able to deal with stakeholders, with clients, with team members. We need to be able to get new joiners up to speed and communicate how the project is going to tech leads and product managers. And we need to write a JIRA ticket that actually makes sense. We need to be able to explain why something's gone wrong and what we're going to do to fix it to someone who's never touched a line of code before. And the skills that I learned as a teacher set me up to be able to communicate well and command a room, although clearly it didn't set me up well for presenting slides remotely. But while the classroom management side of the things does help me more when I'm, say, leading a choir, the other skills are absolutely indispensable, and I'm going to teach you some of these in this talk. So, the two areas of software development that I'm going to focus on in this talk are mentoring others and writing documentation. So not the hands-on, super technical side of really vital and overlooked parts of being a well-rounded developer. They're often called soft skills, which I absolutely hate because they're really important. The word soft tends to have quite a negative connotation. I've heard that referred to as core skills, which I think is great. So we may have to mentor others as a tech lead, or onboard a new hire, teach your kid to code. Or for me, I had to show my mum how to so that I didn't have to keep making copy changes on her website. And we write documentation when we hand over a project, or when we build a new tool or a piece of software for public consumption, or we want to educate people about something. So let's take a look about how we can learn from teaching when it comes to mentoring other people. So what constitutes mentoring? Now, I'm using the term mentoring very generally here, so it doesn't have to be a formal arrangement. So in the UK, we've got things like Code First and Code Bar, which are great organizations that run free workshops for people. It could be onboarding someone new into the team, or taking a more junior developer through under your wing to help them learn the skills that they need to progress. And mentoring is challenging. You need to get knowledge out of your brain into someone else's, and it's necessarily as simple as just telling them stuff. So when you think about what we do every day and everything that's involved with, say, building websites or software, it can be totally overwhelming for mentors to even know where to start, let alone the people that they're teaching. So it's really important for you to let your mentee guide you. It's a two-way relationship, and you need to know why your mentee is there in the first place. So for my English students, there were a few reasons why they might be having lessons. Some of them just wanted to become fluent. Some needed to take IELTS, which is an English language qualification that helps them get into university or get a job. Some were just looking to improve their conversational English so they could get around on holiday. And these goals influence the kind of thing that they need to learn, as well as their approach to learning and even their enthusiasm for the course. So there were also some students who had clearly just been sent to the school by their parents and didn't really want to be there. They were a lot harder to teach because they really didn't engage with it at all. And with the exception of maybe the odd kid who gets sent to a coding workshop, luckily, you don't tend to encounter this as much. I hope you won't anyway. We once had a kid in a class who really, I caught him listening to music in the middle of a lesson, like he really wasn't interested. The only time I ever saw him interested was the day that we learned about swear words. That was fun. So, like my English students, mentees have goals. So why are they learning to code? Why have you been asked to mentor them? And in our world, it's not as simple as being fluent versus learning conversational Kotlin, but there could be any number of reasons, and it's really important that you know what those are from the beginning. So it might be obvious. You might not need to discuss it if it's like onboarding